First of all, my apologies, because I have 51 slides, so probably I will never reach the end unless you give me more time. But I want to thank you, everyone, the organizers, for inviting me over so that I can have this chat with you about recycling. And especially, I'm going to talk about recycling concrete aggregates, not about all waste. So it's only part of the demolition waste. And we are focusing today on the use of recycling concrete aggregates. And of course we can recycle. And the slides you showed us about the study, Annalisa, about the study done by SAI or something. Yes. Well, they're not quite correct, of course, because we recycle more than 95% and not 25% as shown in the slides before. But anyway, this is what we can do. You can do it indoors or outdoors, small companies, larger companies. We have more than 285 companies recycling today in Flanders alone. Flanders is upper half of Belgium. We produce 14 million tons of recycled aggregates each year, which we use in construction. And of course, you have to test them. You have to check the quality of everything. Why do we have to do so? Because there is a European standards for use of aggregates in concrete. And this standard sets some requirements. You can see the requirements here presented on the screen. And you see also on the right some values from experience we have done in the period 2010-2012, because we were running quite a large project on recycling concrete. Now, anyway, the standard says that if you want to use recycled concrete aggregates as an aggregate for concrete, then the size should be more than 4 millimeters, minimum size, and the maximum size is more than 10 millimeters. Then we are talking about aggregates. It's quite important to make the difference between fine aggregates and coarse aggregates. Although, if you're going to take out aggregates from nature, as you're doing at this moment, I did not see any mountains when arriving here in Tallinn. So I guess you're also excavating sand and gravel from the bottom. This is also what we're doing in Flanders. We don't have any mountains neither. So we also take out our materials from nature. We can't continue doing so because of flooding problems and all kind of other natural problems and environmental problems. So we have to import a lot of our aggregates from other countries. This is something which will happen here in Estonia as well. And if I tell you that at this moment in Flanders, we import over 70% of all our aggregates we use in construction, then you can understand that recycling becomes economically interesting. So to go back to our recycled concrete aggregates, you see that we have a lot of parameters that we have to check. For example, we have to check the amount of concrete content. And it's noted here by this figure. And it says that if you want to talk about recycling concrete aggregates, you should have at least 90% of recycled concrete. And if you add some natural aggregates, because if you take out roadworks, then sometimes your curbstones are in natural materials. So anyway, some natural material will also end up into your rubble. So the sum, recycled concrete aggregates and natural aggregates, should be at least 95%. Then we are talking about recycled concrete aggregates as we are talking about today. These are the kind of top-class aggregates that you can use in concrete again. If you look at the bituminous parts in this, it should be less than 1%. If you look at other parts like glass and so on, it should be less than 0.5%. If you look at floating parts from wood or paper or whatever, it should also be limited to a volume of 2 cubic centimeters per kilo of material you use. Flakiness. Flakiness it has more to do with the concrete technology. If you have a lot of flakes in your aggregates, then you can't make very good concrete. So flakiness is also limited to 20%, to a value of 20, sorry. Dry density, that's quite important. Dry density should be above 2,200 kilos, okay? Fineness contents, if you recycle concrete, then you will always see that you have a lot of fines being produced, depending also on the kind of crusher you use and so on. Now, the amount of fines, well, concrete technology, you don't always want too much fines, but is it a problem? Well, you can deal with it anyway. Now, we say that the fineness content should also be less than 1.5%. That's the standard that's explaining this. Resistant to abrasion. Okay, resistant to abrasion, the value of this should be less than 40. The lower the value, the better. Natural aggregates will have a Los Angeles value of about 25 to 30. So why should it be less than 40? Because there is a relationship between the frost resistance of the aggregates and Los Angeles abrasion. That's the main reason. Otherwise, I don't think there's quite a lot of evidence to support this. Water-soluble sulfates, because this can have an influence also on the binding of your concrete. Water absorption should be less than 10%. Okay. And influence on initial binding by all kind of chemical components which could be inside of your aggregates should be limited to, originally the standard said 10 minutes, but you cannot measure this. So now the standard is changed to a value of 40 minutes. Now, these are the requirements set by the standards. And are these requirements really feasible for our recycled concrete aggregates? Well, several studies prove that it's possible to reach these values. Okay? And the higher the value you set, the better concrete you will get at the end. That's also true. Now, is this true? That's what I want. So we did some study about this, and I'm glad to present some results from this. So if we take a closer look to some of these parameters, you will see that if you look at the definition again, at least 90% of coarse recycled concrete. If you look at material, then you will see that indeed these are values for the Los Angeles abrasion. Indeed, the value is lower than 40. So we can reach this. Okay, that's fine. If we look at Flakiness Index, again, if you look at this section, this is our coarse recycled concrete aggregate. Yes, indeed, we see that we are far below 20. I think we could even say that we could reduce this value to 15. It still would be okay. If you look at flakiness, we experimented something about the flakiness index versus the particle size, because you can imagine if you use very fine particles, maybe you will have more flakes, or in the opposite, if you have larger particles, maybe, yeah. But there's no proof found for this, so we see that flakiness index is always far below the limit. It's never reaching the value 20, so that's okay. Again, if you look at the density is quite important. The dry density, that's the value we look at. Dry density, remember, recycled concrete aggregates, they have more pores than natural aggregates, of course. So we see that if we look at this section, more than 90% recycled concrete, then again, it's okay, you always will have more than 2,200 kilos. If not, if it's lower, then you have mixed recycled aggregates. This is our class B aggregate. This is class A, that's the best quality, highest quality, that's the one we use. If you look at water absorption, well, we see that in general it's always less than 10%. If you would use the fine particles, the sandy particles, 0.0 to 4 millimeters, then you would find maybe 10% water absorption. But for the coarse aggregates, mostly it's between 5 and 8. If it comes from road pavements, then it's mostly between 4 and 5. The variation is lower. But you can see also from our experiments that we are well within the limit of 10%. The lower, the better. If the water absorption is very low, then you don't have too much problems in the workability, which will change anyway. If you look at the content of the fine particles, then again you will see that it's really less than the value set, 1.5%. And this is in fact the kind of aggregates we are using, at least 4 millimeters, and then the upper side more than 10. I prefer to use 820 for some reasons, but okay. But even if you would use all material, 0.40 or 0.32, then you can still use this material according to this parameter, but you will find more fines in these categories of aggregates. That's true. If you look at the composition to see if you have a lot of red brick or glass or things like that, again, there is a difference between recycled concrete aggregates and mixed aggregates. And you will see that indeed we have less than 0.5% or about 0.5% of other parts present. That's sometimes the most difficult part to look at. Now, we want to use this in concrete. And the kind of concrete we want to use it in is in this section. Because in the upper section, well, this is lean concrete. Nobody uses lean concrete. Nobody makes this in the concrete plant. So why should we focus on that? It's only 5% of the market. So we don't look at this. We want to look at this kind of concrete classes, strength classes, 2025 up to 3037, because then we can reach about 50% of the market. Give me a sign when my time is up, okay? And maybe in future, at this moment we are running some projects to see if we can also use this in higher classes. Not so easy, but we're trying to find a way also to introduce this in the precast industry. If we want to use this in concrete, then we always have to look also to the exposure classes, environmental exposure classes. Now in Belgium, this is the way we present it. We have exposure classes indoor and exterior exposure. EE is from environmental exterior exposure. So the kind of concrete we want to use, at this moment, we can use it indoors and also for foundation. We can also use it over there. And starting from next summer, summer coming now in 2017, we'll probably also be using it for environmental exposure class 2, which means that it can be used outside but sheltered from the rain. So it's dry, so you don't have frost problems. And also in exposure class EE3, which means that it can be wet and it can be exposed to frost also. It should also be possible. We have done a lot of experiments to prove the possibility anyway. EE4 is more difficult because here you can have some de-icing salt on the concrete, and that is more aggressive towards your concrete, even for standard concrete. So, if we look at use of coarse recycled concrete aggregates in ready-mix concrete, let's say, in Belgium, in Flanders, and moreover in Belgium, before 2002, before we ended our Valerecon project, we could use recycled concrete aggregates for 20% only in lean concrete, strength class 12-16. Since then, we have been using this in strength class 25-30 for indoor applications. Again, only 20%, but that's enough. That's enough. It's okay. And starting from next summer, we will be using it in three volumes, and 20%, 30%, and 50%, depending on the exposure classes, so the kind of use, and we will use it up to string class 37. In other countries, if you look at the Netherlands, Germany, Norway, you can see that they also use quite a lot of recycled concrete aggregates, depending also on the kind of application. You always have to look into the kind of application you want to use it in. That's quite important. The kind of string class you want to look into, and so on. Now, let's think about some influences you can have on the recycling concrete aggregates. First of all, you need a very strict acceptance policy at the gate. So if you have a recycling industry, recycling center, what kind of material would you accept? You can accept everything, but if you accept mixed waste, then you should stockpile it separately. If you accept also concrete, stockpile the concrete in another stockpile, so that you can make the difference in qualities, otherwise it will become difficult. Selective demolition is also much better. I've been working in China these past 6 years, and in China, if we talk about demolition, it's not one building, it's a whole area they demolish, all at once, all mixed. So there it's really difficult to start recycling this material into concrete products. That's what I want to tell them again next month when I'm invited over there by China Railway Company, that they have to start selectively to demolish things, otherwise it will become difficult. Now, these two parameters alone, selective demolition and acceptancy, have an influence on the composition and the cleanness of the material. All these parameters that you can see over there, these are influenced by the way you treat your material, the way you accept it. If you are going to process the material, of course you have to crush it to reduce the size, but you can do it at one time or in 2 times. It's better, if you want to reach the high quality aggregates, to do it in 2 steps. First, to reduce the size and also start cleaning up. So separate your iron, take out the metal parts, take out wood and paper, insulation and so on for the first time. Then crush it again in smaller sizes. So you have to sieve it, and again you can clean it. Then you will have the best quality. That's the kind of quality of recycled aggregates we will use in concrete. Of course, this is more expensive to have a 2-step approach than a 1-step approach, but the quality is much better, so that you can really use this in the same way as natural aggregates. And if I look at the cost for this, we can sell recycled concrete aggregates, let's say, for about 15 euros per ton, while the natural aggregates cost 20 euros per ton. So there's still a difference in price, but the difference is not that large. And the better they become, the higher the price will be for selling your recycled concrete aggregates, the better also you will be using it. And if most companies, recycling companies, also have a concrete plant next to them, so they use their own material. For them, it's important to have good material, and also that the cost is not too high. They can sell it for 15 euros, but for themselves, the cost is only about 10 or 12 euros. So they make a profit out of this. So, of course, you can use all kinds of sorting out techniques, sorting out techniques and cleaning techniques like wind sifting, washing and so on. This has an influence also on these parameters, while single stage and 2-stage crushing has an influence on density, Los Angeles abrasion, water absorption. If you look at the influence on recycling concrete, then of course density is important, water absorption, flakiness, recycled concrete, percentage of use of recycled concrete aggregates or water reducing agents. These parameters all have an influence on the parameters of your concrete. That's pure concrete technology, of course. Less important, but to some influence, is the particle size distribution, because you can you can sieve this in several fractions and reassemble this. So for workability and mechanical properties, that's less important. We are not the only one who found this kind of results. Some other researchers has also found the influence. For example, the influence between water absorption and the original strength of the concrete. Parent concrete, is it important to have better kind of concrete? I don't think it's really that important. If you have arrays of, let's say, 10 megapascals from 20 to 30, then of course the water absorption has a larger influence, but between 30 and 40, the influence is not that important anymore for the water absorption. Anyway, you can deal with this. The influence of the parent concrete also has something to do with the amount of attached mortar which clings to it. In fact, that's the real problem in recycling concrete, the attached mortar. If you can get rid of the attached mortar, then it would be the best. And at this moment, worldwide, a lot of researchers are trying to take out the attached mortar. Only at this moment, nobody succeeds to do this in an economically way. If you look at the water absorption, as we said before, it's mostly between 5 and 7%. That's what we find. And if you look at this, 5 to 7% attached mortar is about 35 to 45% attached mortar. So you will see again, you're in the region of 2,300 kilos per cube density. Mind you, this is not the dry density, this is the saturated surface dry density, which is always about 100 kilos per cube, higher than the dry density. Again, you can see that the influence of a two-step crushing is important, because if you use a two-step crushing, then you will have less attached mortar. More attached mortar will come free in the second step. So that's why it's important. You will reduce the amount of attached mortar, so you go that way. So you will have a higher density, better quality. Here again, if you go back in attached mortar, you reduce the amount of attached mortar, then the water absorption also becomes less. It's always better. If you look at the Los Angeles value, again, you will see that a reduction of the attached mortar gives you better quality, lower Los Angeles. If you look at the water-soluble sulfates, again, if you have a two-step crushing, removing more of the attached mortar, then you will see that the amount of water-soluble sulfates is reducing. Again, it's better. So you can continue on this kind of stories and see that two-step crushing is always the best. So the message is really, if you want to recycle concrete into recycled concrete aggregates, which are fit to be used in concrete according to the European standards, then you should have a two-step crushing industry for this. Yes, there is a relationship between the water absorption and the dry density. So what you can see here, mostly we are in this section because we're using everything above 2,200. And indeed, again, you see that we are between, let's say, 4 and 8%. So let's look at the influences on of the production process on the recycling concrete quality. So again, you should restrict the kind of concrete you're going to recycle. A good acceptance policy is important. You can even separate concrete from road design and concrete coming from structural elements from buildings, because that's also quite a difference between both of them. You separate materials before crushing, so you take out the mixed rubble and you separate it from concrete. And again, that's what I said before, separate stockpiling is important. You screen out the oversized material, then you crush it twice, and you can separate the other impurities by hand packing, magnetic separation, wind sifting, washing, and other modern techniques. At this moment, there is a European project called HYSER running, and they are experimenting the use of X-ray, near-infrared, color sorting, eddy current sorting, to take out all kinds of residues you don't really want in your aggregates. And of course, you can wash the aggregates. If you look at other influences on the production process, so the two-step crushing process is better. Or you can try to find another way to remove the attached mortar. Like in Japan and in Korea also, they use heating, but they have another kind of aggregates. In Belgium, we use a lot of limestone. We cannot start heating up the broken concrete because the quality of your limestone will be reduced. Above 600, 700 degrees, you get a degradation of your limestone. So we can't do it. And it consumes a lot of energy. So we don't think that's the solution. In the Netherlands, there is a company called Smart Crusher. They are claiming to build a smart crusher, which is removing a lot of attached mortar. Only, I have never seen any machine built by this company, and they are already talking about this during the past 4 years, so I don't think they will succeed. It's a problem. It's not easy to do so, to take it out. We also have just launched a new project to make a new machine, and maybe we will find the best machine to remove the attached mortar, but I'm not quite sure about this yet. So the methods which are studied at this moment is heating and rubbing, the eccentric shaft mortar method, which is a kind of rotary crusher, only with a vertical rotor instead of a horizontal rotor. Takes off more, but not all. And then just grinding, you could start grinding everything into sand diffraction, maybe. Only at this moment, we are not allowed to use recycled sand in concrete due to some contaminations which could be inside, but there is no real proof for this. We have started a project 1st of January to study the use of fine recycled concrete aggregates as sand. If we look at the water absorption in recycling concrete, if we make concrete nowadays and we use it outside, then of course we want to be sure that it's frost resistant. And to make it frost resistant, then you don't want your concrete to absorb a lot of water. So that's the initial water absorption from outside to inside. If we look at the water absorption in recycling concrete from at the surface, we see no difference. It's the same, because the finishing of the concrete is also the same. So the speed of the water ingress is about the same. If we look at water absorption and porosity of recycling concrete, then we see that even when we use 20% of recycling concrete, then it's not worse, it's about the same. It's sometimes even a little bit better. It's a bit better because we have smaller pores. The pores are filled with some filler. We have some filler components in our aggregates, some fines, and they block the pores. So that's why when using only 20%, sometimes you can get better results. But if you use more, then again, we have more pores in the aggregates, then it will go up. Same for carbonation. If we look at the carbonation speed, then again, we see that there is no problem when you are using recycled concrete aggregates to make recycling concrete. At least if you use about 20%. If you want to use more, then it's doubtful. But certainly when you use about 20 and even 50%, in Project Valericon we used 100% of the coarse aggregates replaced by aggregates which are recycled, and we found no problem with carbonation. We have the same kind of carbonation. So as you know, carbonation starts at the surface and it reduces your pH of your concrete from 12.5 to 9 or 8. But when you reach 9, then you might get corrosion of your reinforcement. That's the reason why it's important. Anyway, when we look at the speed of the carbonation and we look at the environmental in exposure class 3, which we want to use the recycling concrete in, then the maximum water-cement ratio is 0.5. If we look at 0.5 water-cement ratio, then the speed is less than 1 millimeter per day square root. So we should not have any problem in this section, in this part, if your water-cement ratio is less than 0.5, you should not have real problems with carbonation or speed of carbonation. That's also what you see here. Red line is natural concrete or standard concrete, and the blue dotted line here is using 20%. So even there you can see that in this area using material up to compressive strength 35 megapascals, you will have about the same values. Also for the permeability, you will see that the carbonation speed in the area less than 1 millimeter per day is about the same as for standard concrete. So it should not be a problem. And many researchers have looked at this and they found that really the carbonation depth should not be different. It's about the same, maybe 5% more or 10% less, depending, it's all depending on your concrete composition and the way you treat your concrete as well. You have several parameters which influence the carbonation. If you look at the frost resistance, again, many researchers conclude that there is no real reason to believe that you will have a problem with frost. Indeed, if you compare the frost resistance, the blue is 0 cycles and 65 cycles of frost resistance, frost thaw cycles. You will see that for recycled aggregates, it's about the same level. It doesn't make that much difference. And for example, here in this slide, you will see that this is standard concrete. After 30 cycles, the standard concrete became worse. So, in fact, there is no reason to believe that even for frost, there should be or there will be a problem. You can make good concrete using recycled aggregates, also frost resistant. So these are the conclusions. In fact, also from some Chinese researchers, a lot of research being done in China. So the conclusions are, if you use 20 to 30% of coarse recycled concrete aggregates in recycling concrete for exposure classes outdoors, sheltered from the rain or not sheltered from the rain, the production of recycling concrete aggregates, you should know the facts. Acceptance policy is important, sorting and cleaning is important, crushing technology is important. The production of recycling concrete, again, you should know what you're doing. So your mix design should be okay. You should take care of the water absorption and compensate the water absorption. Or you should use some admixtures, additives, to have the same workability. Frost resistance, again, the mix design is important, is much more important than the influence of the aggregates, should not be any problem. And loss of mass and slab test, for example, should well be below the requirement of 500 grams per square meter. And carbonation, there is no more carbonation in recycling concrete than in standard concrete. So yes, we can recycle. We can use it in structural elements. And if you want to use it in structural elements, you need some more research because the elastic modulus is important then. Compressive strength is important, flexural strength is important, the modulus is something else. But anyway, you can do this, you can fix the problems with fresh concrete, workability, this can be handled, and also the properties on hardened concrete can be measured and can be compared with standard concrete. I will finish my presentation here because it goes on with some other material about elastic modulus and other parameters. But at the end of the day, if you're still awake and you're still interested, I can continue, but you have to ask them. Thank you very much. Questions? Yes.
Thank you, Luc. Do we have any public questions at first?
Maybe I just missed, you had different classes of the materials, EE1 to 4 and ES1 and 2 was also mentioned. What is it?
Yeah, they are special environmental classes which are used in, for example, exposures to let's say in a swimming pool, the environment in a swimming pool, you have a lot of chlorides inside. That kind of environments, also in the industry, chemical industry, these are special kind of exposure class. Yeah.
Anybody else? Yeah.
From building materials teacher over there. Do you have any requirements or do you inspect the concrete itself before you reuse it?
In fact, I don't think that's necessary, and you can't do this. You could do it, but we don't, because the demolition contractor is not interested in this. He's just interested in demolishing, and he brings his material to a recycling center. It's not always the same company. If it's the same company, well, this could happen that will check the concrete quality before they will crush it. But mostly it's not done. And in fact, if you use this two-step crushing industry, then at the end, it doesn't matter really. I can even say, if you crush weak concrete, then the attached mortar is removed much easier. So to me, it makes no difference. I will check my material at the end, and I will deal with the parameters coming out of the testing in the lab. And then I will design the concrete. I think that's the best approach.
Do we have any more public questions? Okay, let's move on. Is it possible to recycle recycled concrete? If so, how many times could be the limit?
Yeah, since buildings are mostly lasting at least 30 years, 40, 50, some 100 years, this has not been studied at this moment. But it's a good question, because now in June, one of my thesis groups, one of my groups of students will present their master thesis on continuous recycling to see. So I'm not going to, in detail, to give answers now about the drop of quality. There is a slight change in properties, but not that much. It's possible to do it.
Some more. What would you advise for countries that don't recycle concrete as good as you do? Where should we start? Is the government support important in it?
Yes, of course. And I think a good policy for recycling is important in all countries. That's the first thing. What we did in Flanders is quite easy. We said, everything that you can recycle should be recycled. You're not allowed to dump it anymore. You cannot landfill it, because we don't have the space for landfilling. That's easy. So we are not allowed to do it. And if you want to landfill, you will pay high taxes. Nobody wants to pay taxes. We pay, if you want to landfill this, you pay 150 euros per ton. Can you imagine? This morning, I don't know how much tons it was, the demolition, but you can calculate how much it would cost. But when you bring your demolished material to the recycling business, then at the gates you will pay a fee. And it depends on the composition. If it's mixed rubble, at this moment in Flanders, you pay something between 3 and 8 euros per ton. If it's pure concrete, then depending if it's coming from road design or not, sometimes you pay nothing. They accept it for free. They're even willing to pay 1 euro per ton because they can use this in their own company. So it's business. We have 285 recycling companies in Flanders, so it means that we can deal with this. So I do not agree with the fact that recycling is always more expensive. It's not true.
It's all about the taxes.
No, not only this, but transportation cost is also important. Energy cost is important. If you recycle metals, for example, you only use 60% of the energy. So that's also transportation of ores and processing of ores and so on. You should look at the complete picture.
I will pick the last question. What is your opinion? Will all the European Union countries achieve the goal for 2020?
No. No, it's easy. In 3 years' time, it's not possible. It took us, in the 90s, when we started, it took us at a certain moment, I think 5 years to go from 70% to 95% of recycling. So I think it's impossible to reach this, but Europe should invest more in this. They should promote more this and stimulate countries to do so. And we should share more knowledge. That's something we should do. We should spread the knowledge we have amongst each other and organize visits to companies which are recycling already to see what we are doing. Next month, for example, I have some colleagues and companies from Czech Republic who are coming to Flanders to see what we are doing in Flanders, because at this moment they do about the same as in Estonia, backfill. And I say that's a pity when you only use this kind of nice material for backfill. You should do more with this. So that's my answer.
Thank you very much.
You're welcome.
On behalf of the team, again, we will give you a small... perhaps you can ask your questions later on, because we will have a short break, and I expect that you won't go away right now. So perhaps you will have a short time afterwards and ask some more questions. I didn't ask all the anonymous questions as well, because we just don't have that much time. I'm sorry, but yeah, I will resume. We will have a small present for you, a hammer again, to crush the concrete. I hope that you won't have any problems bringing it back on the plane.
Yeah, on the plane, yeah. The metal detector. Thank you very much. Thank you.